Okay, everyone type in y equals root x. Ty, why can't we have yer?
Only because you can't have a negative root.
True, you can't have a negative root. Can you have a 0?
Yes.
Yes, you can. So, if we were looking at just this one, we would say x has to be greater than or equal to 0, right? So that's why it's restricted, because you can't actually have negatives. Okay? So if we go to actually graph this one, we can graph it right off our calculator, or we can use our t-tables like we were taught many, many moons ago. So we had x and y. If I put in a 0 for x, which is where I can only start because I know that x has to be greater than or equal to 0 because what's under my square root has to be. This is the square root of x. Y is the square root of x, the square root of 0, so it's at 0, 0. So that's why we start there. Then I have 1. Then I would have the square root of 1, which is 1, 1. If I use 2, I get square root of 2. So I'm going to use 4 because it's nicer. Because the square root of 4 is 2. It's a nice whole number. Could I use the other ones just plot decimals? Yep. Next one I'll go to is 9. Square root of 9 is 3. So, sketch the graph, done. State the transformations, there aren't any. This is the base. This is called your parent function. It's the function before any transformations happen. State the domain and range. What's the domain of this one? In set notation. X such that X is greater than, equal to 0. X the noun of the reals. In set notation, that would be a square bracket. Zero to infinity. Why is it a square bracket? Yeah. What's my range of this one? Y such that y is greater than or equal to 0. YER. What's the only thing that can move that domain? Yeah, moving it right or left, right? If I stretch 0, does it do anything? Because the parent function starts at 0, 0, the only thing that can make you move is a horizontal translation, can move you right or left. And then a vertical translation can move you up or down. Now the graph, if there is no reflections, the graph is up and to the right, correct? This graph is up and to the right. If the graph is not up and to the right, there's a reflection of some sort. Keep that in mind. If it's down, there's a reflection in the x-axis. If it's left, there's a reflection in the y. So the way to tell if there's reflections is if it's up and right, there's no reflection. And my x and y intercept is the same for this one. It's at what? It's at the origin, 0, 0, yeah. Always put them in coordinates. Do I actually have to put y equals x square root x minus 2 in my calculator? No, I can use transformations. What happened here? It's with the x, it's x minus 2. What happened? Like transformation-wise. What? Yeah, it's a horizontal translation 2 to the right. So the entire graph of root x just moves 2 to the right, and we have root x here, correct? So I'm going to move it 2 to the right. I don't need to actually do the table. Could I do the table? Sure, I don't need to. So 0, 0 moves to 2, 0. 1, 1 moves to 3, 1. 4, 2 moves to 5, 2. And then 9, 3 moves to 10, 3. 6, 2. Is that 6? 1, 2, 3, 4, 5, 6. Why am I not moving them 2? That's the question. I started moving them 2 and then started moving them 1. It's a real thing. All right. So this one was right. 4 is 16. And then 9 is 11. It's up and to the right, so no reflections have happened, correct? Which we know no reflections have happened because there's no negatives in our equation. So let's talk about this. We know we have a horizontal translation units right. How can I find my domain easily without actually having to look at this graph? What's underneath the radical has to be what? Okay? What's under the radical has to be? Is the same answer you gave last time.
Positive.
Yeah, has to be positive or equal to?
0.
0, right? So we have x minus 2 has to be greater than or equal to 0 because all of x minus 2 can only be equal to 0 or a positive number, right? And then we add the 2 over. And we get x has to be greater than or equal to 2. So that's my domain, which, as you can see below, is my domain. But I didn't have to sketch the graph in order to figure it out. So it's set in set notation, set in interval notation, it's 2 to infinity. Is my range going to change? Has anything happened to my y's? No. So will my range, my parent function's range change? No. The parent function's range is y is greater than or equal to 0. It stayed y is greater than or equal to 0 because nothing happened to my y's, right? So through mapping and transformations, we can make decisions without having to graph it. Now remember, logs and exponentials are either greater than or less than, right? There's no equal to's because of asymptotes, but radicals are equal to because you can equal 0, right? Don't do stuff off of memorization, do stuff off of understanding. Logs and exponentials can't be equal to when you do the domain and range of each one of them. It's not YER or XER. But radicals can equal because it can equal 0, because you can have root 0. And then this one would be 0 too. Does this one have any y-intercepts? No y-intercepts because the entire graph shifted 2 to the right. So it's completely shifted off the y-axis, right? So we have no y-intercept. And an x-intercept. At 2, 0. So if you're doing transformation and you're using mapping to draw it, right? You're mapping it off of this first graph, your parent function. So your 0, 0, 1, 1, 4, 2, 9, 3 are going to be your original points, and then you're going to use mapping to get your new ones, right? This one we didn't have to do because it wasn't as complicated. But these ones are. So what's the catch for C that I have to do first before I can use mapping? So I have to have y equals 3 square root negative 1 x minus 1. What about this one? I can take out the half, right? Negative 2 root 1/2 x minus what? 8. 5 by half means multiplying by 2. So I want you guys to use mapping and these coordinates 0, 0, 1, 1, 4, 2, 9, 3 to draw your new graph. I don't want you to just type in your calculator. What would the mapping be for this one? Help me out. X, Y becomes what? Negative X. Remember, words and mapping are the same. So I'd be moving 1 to the, which way am I moving? 1 to the what? 1 to the right. So I'm going to add 1. And then no flipping y. So I get 3y. That's it. And I'm going to plug in 0, 0. I'm going to plug in 1, 1. I'm going to plug in 4, 2. And 9, 3. So I want you to sketch these two graphs. So if we go 0, 0, we're going to get negative 0 plus 1, comma 3 times 0. So our new coordinate is going to be at 1, 0. So I go 1, 0, here. Remember that the only thing that moves that initial point is a horizontal translation or a vertical translation, right? So our initial only moved to 1. Also, reflection could cause it to go to the other side. Now here we have negative 1 plus 1, comma 3 times 1. So I get 0 and 3. Wait a second, it's going this way. Why is it now going this way? There's a reflection in the what? In the y-axis. Okay, then I get negative 4 plus 1, comma 3 times 2, which is negative 3, 6. And then we'd get negative 9 plus 1, comma 3 times 3. So now I have negative 8 and 9. Now if I go to do my domain, I have negative x plus 1 has to be greater than or equal to 0. Do we agree? Then I get negative x has to be greater than or equal to negative 1. Then I divide by negative 1. What happens when I divide by a negative with an inequality sign? It flips. So I get x is less than or equal to 1. Is that true? Yep. So your domain can come from just setting what's under the radical greater than or equal to 0. So my domain is x such that x is less than or equal to 1. X is the element of the reals. So I get negative infinity to 1, close bracket, for interval notation. And then my range, it didn't change. Why didn't it change? What affected my y's? Just a vertical stretch, correct? Does a vertical stretch affect a 0? No. So my range is still y such that y is greater than or equal to 0. Y is an element of the reals. You have an x-intercept at 1, 0. Don't short form on a diploma. And a y-intercept at 0, 3. We go to do the mapping of the other one, and we get x, y becomes, x is going to be 2, because x is always flipped, no flipping y's. So I get 2x plus 8, comma, negative 2y plus 3. Y is the easiest because nothing changes, as long as you have it in y equals. Then we plug in our original points off our parent functions. We get 0, 0. Becomes 2 times 0 plus 8, comma, negative 2 times 0 plus 3. So I get 8 and 3. So the only thing that can move that initial point is vertical and horizontal translations. Because other than that, we're just multiplying by 0, which changes nothing. Right? So this one's 8 and 3. 1, 2, 3, 4, 5, 6, 7, 8, and 3. Oh, it's going to be up and to the right, but down to the left. Oh, right down and to the right. I'm going to change it. I'm going to go like this. I'm going to make my x scale 2. So 2, 4, 6, 8, and 3. So my x scale and y scale don't need to be the same. However, if it's a y scale of 1, the whole time it's a 1. If it's an x scale of 2, the whole time it's a 2. Remember that when you change your scales off of 1, you have to remember that. So like you might start at 2 and then you'll like flip back to 1s and then it's all wrong. You have to remember that. Okay, then I have 1, 1. will become 2 times 1 plus 8, comma negative 2 times 1 plus 3. So it's going to be at 10 and 1. It's going downwards. Why is it going downwards? I have a reflection in the what? The x-axis, so it's going to go down. So instead of up and to the right, it's still to the right because there's no reflection, but it is down instead of up. And then I have 4, 2 becomes 2 times 4 plus 8, comma negative 2 times 2 plus 3. So now I'm at 16, comma negative 1. 2, 4, 6, 8, 10, 12, 14, 16, negative 1. That's the right way. And then 9, 3. We run into problems. So it's going to be 2 times 9 plus 8, comma negative 2 times 3 plus 3. So I get 18 plus 8, which is 26, which is too big. And then negative 3. So I'm just going to extend this a little bit. So can I figure out my domain right from the get-go? Yeah, I don't actually have to draw this. I just take what's under my square root symbol and set it greater than or equal to 0, because whatever underneath my square root has to be greater than or equal to 0. The number under that can't be negative. Move by 4 over, I get 1/2 x is greater than or equal to 4, and then times by 2, x is greater than or equal to 8. Why didn't I switch my symbol this time? There's no negative. And if I multiplied by a negative, would it do anything? No, the only way a sign flips is if you divide by a negative. That changes an inequality sign. And is this greater than or equal to 8? Yes, it's 2, 4, 6, 8. Remember, it's a scale of 2. So my domain is x such that x is greater than or equal to 8. X and L are the reals. My range is less than this time. Why? Because of that reflection. So we get y is less than or equal to my vertical translation, 3. That's the only thing that can move to 0, y-er. Yeah, your x-intercept would just be plotted, whatever it is. 10 and 0? It's what? 10 and 1? I mean, it's 12. Okay, but let's check it out. So if we want our x-intercept, what do we do? When I say x-intercept, you say what? Y equals 0. So we go 0 equals negative 2 square root 1/2 x minus 4 plus 3. So I get 0. Actually, I can move the 3 over by subtracting it. Negative 3 equals negative 2 square root 1/2 x minus 4. Divide by negative 2. Just 3/2 equals the square root of 1/2 x minus 4. How do I get rid of the square root? Square it. So I get 9 over 4 equals 1/2 x minus 4. Add 4. So I get 25 over 4 equals 1/2 x, and then multiply by 2. So I get 25 over 2. So my x-intercept is at 25 over 2 and 0. And in any unit, they can ask you for x and y intercepts. You plug 0 in for x, it's a y-intercept. You plug 0 in for y, it's an x-intercept. Solve algebraically. We're going to flip over to number 3. We're skipping number 2 till tomorrow, so we're coming back to that. We're just doing the other stuff. All right, we're at 3. So what's the only thing that can change my domain and range? The only thing that can change my domain and range is my horizontal and vertical translations, correct? So technically, could I put any stretch? If they just give me the domain and range, I could put any stretch on it and it wouldn't matter because the stretches don't change my domain and range. They can throw in any stretch they want. The only other thing you have to watch for is your inequality sign. So this here is my horizontal translation. This here is my vertical translation. How do I know if there's any reflections? Inequality sign. If it's not greater than, there's a reflection. So this one is greater than. So is there a reflection in the y-axis? Nope. This one is not greater than. It's less than. So there's a reflection in the x-axis. So they want us to write the equation of a radical function with each domain and range. So I'm going to have y equals, what affects my y's? Well, I have a reflection in the x-axis, so I get a negative in front of my square root, and a plus 2 at the back. In the bracket, I need a horizontal translation of 5 to the right. So what am I going to put in here? Done. Could I add any stretch I want? Yeah, the stretches don't affect it. Some people get thrown off. They'll be like, but they put like a stretch of 4. How do I know that? Because they can put a stretch of whatever. It doesn't affect the 0, 0 that's at the beginning, right? So don't let that throw you off. Okay, this one is my horizontal translation. This one is my vertical translation when it comes to radicals. This one is less than. So now I have a what? Yeah, reflection in the y. This one is greater than nothing, right? So now I'm going to get y equals square root something. And at the back I have minus 4 because I need to go down 4. Now remember when you put in x's, put in brackets, right? Because if I go like this, I can go 1x. I need to move it 2 to the left. So what am I going to put here? Just a plus 2. We agree? Because if I have a 1 in front of the x, my horizontal translation is correct. What am I missing, though? A negative sign in front of the bracket. Yeah. Then we're going to flip over. So this one says, write the radical function that results in the transformations to the graph of y equals, it should say root x. That's it. Typo. A, B, C, D. Go. Give me the new equation. Okay. This one we're going to get y equals vertical stretch by a factor of 3, reflection in the x-axis, translation 4 units right, 2 units down. This one is a horizontal stretch by a factor of 4, or a quarter, sorry, so it goes in as 4. A reflection in the y-axis, so negative 4. Translation 3 units up, plus 3. And then 5 units left, so I need to go in brackets and go x plus 5. This one we have a vertical stretch by a factor of 2, horizontal stretch by a factor of 3, so I get a third. 4 units left, x plus 4 in brackets, 1 up, plus 1. And then D, vertical stretch by a factor of 3, horizontal stretch by a factor of a half, so it goes in as a 2. Reflection in the x-axis, so that's a negative y. Reflection in the y-axis, that's a negative x. Translation 6 left, x plus 6. your homework. One thing I want to also share with you is sometimes they do this. And they say determine the horizontal stretch. And people will say there is no horizontal stretch. Because the horizontal stretch would be here in front of this x. Is there any way I can get this number to go inside here because it's the square root? What would it be? What would it have been in order for it to come out as a 4? 16. So it would be y equals 4. That's a lie. The 4's gone. Y equals square root 16x. So it's actually a horizontal stretch by factor of 116. Because it flips, remember? Same thing, vice versa. They could go y equals, most people are better at this one, 25x. And they could say, okay, what's the vertical stretch? And people say there isn't one. There is. 25 can come out as a what? So it'd be a vertical stretch by a factor of 5. Okay? Radicals are tricky like that because you can move them in and move them back. Often people will move this in as a 2. Watch yourself. When you're moving it in, you're squaring, right? Taking it out, you're squaring.